Hello guys, this is Ayush. I welcome you all to the workshop. So you have been learning about electrical components for long, isn't it? But the fact is that many of you may not have got a chance to work with these components in real life, how these components look like. So we at Electronics Club in this workshop aims to provide you a real insight of how these components look like and what are their practical applications. So we will look these components one by one. Let's start. First is breadboard. What comes to your mind after hearing this name breadboard? You might be thinking of this, a bread kept on a board. But obviously, this is not an electrical component. We are not going to talk about it. So the next question arises is, why an electrical component is named breadboard? So the answer lies here. Many years ago, when electronics were big and bulky, people used to grab breadboard and build circuits on it. Since then, this component is named as breadboard. So by now, many of you might have guessed what a breadboard could be. If you are thinking of something on which we build our electrical circuits, you are actually very close. Before looking about modern day breadboards, let's talk about its development briefly. Before, in 1960s, people used to build circuits using this technique of wire wrap. But as you can see in this figure, when circuits are big and bulky, it gets a mess. So there needs to be some technique in which we can build our circuits easily. There came the modern day breadboards. Here you can look at the figure how this modern day breadboard looks like. In this, all the internal connections are made and just you have to understand the connections and build the circuit accordingly. This is used widely for testing the circuits before actually implementing it somewhere on PCB or any other place. So let's look at the connections in the breadboard and understand it. You can see two power lines and on the top and two on the bottom. In these lines, battery or any other power source is connected. Positive terminal is connected to this side and negative to this side. Similar thing is on the bottom also. These power lines are sorted horizontally, means the voltage is same on this horizontal line. Rest on the breadboard you can see the lines marked from A to Z and here from 1 to 30. On this part of the breadboard, all other electrical components are connected and the circuits are made. These parts are sorted vertically, but A to E is sorted separately and F to J is sorted separately. These parts have the same voltage. Keeping in mind these connections, we have to build our circuit. So I guess you have understood the connections on the breadboard. So how will you connect a resistor on the breadboard? Well, you can connect it horizontally, but you can't connect it vertically because resistor is a two-terminal device, and when you connect it vertically, the two terminals will get sorted and there will be no current flow. So you have to keep in mind. If you are not very clear now, you will get clear once we simulate it on the Tinkercad later of the workshop. So let me ask you another question. How would you connect an IC on a breadboard? Well, you might be thinking what an IC is. Don't worry, we will cover it in the same workshop. But try to answer how we will connect it on the breadboard, keeping in mind the connections which I have explained you earlier. Write your answers in the chat box. I am giving you few seconds. Well, as you might have guessed, we have to connect it like this. This is the only way we can connect an IC on a breadboard, because if we will connect it horizontally or vertically, many of the terminals of the IC will get sorted and it will not work properly. So we have to connect it like this. So now we have a fair understanding of how a breadboard looks like and how we can build circuit on it. But for a circuit to function, we need power sources. So what are power sources? Here is some of the common examples of power source shown. You can look at it. For example, this is a battery, one of the most common power source. You might be very familiar with batteries you are using all day round everywhere. What is battery basically? It is a connection of electrochemical cells which provide power to your electric circuit. So let me ask you a very basic question. What is the difference between a real battery and an ideal battery? Well, this is a fairly simple question you all might know. So let's move forward. Have you ever broken an electric component at your home? I guess many of you might have broken, and you may have got scolded for that. So if you have done so, you might have got to know the circuits which are shown here in this figure. You might have seen them before. Then what are these tiny components square shaped? Or what are these colored cylindrical component on this circuit board? What are they? Yes, they are resistors. So what do they do in the circuit? Why they are used? The basic use of resistor in a circuit is to resist the flow of current. They decide how much amount of current to be flown through the circuit so that the component gets appropriate amount of voltage drop through it. They are basically passive components and do not supply active power. So well, how do you know what is the value of the resistor? It is nowhere written on the resistor. So you might remember in your previous classes, you might have learnt about color coding. So let's review it quickly. Here we have three types of color coding: 4 band, 5 band and 6 band. Depending upon the accuracy with which we want to calculate the value of the resistor, we are using different types of color coding. For example, if we see this 4 band, what is this? The first two of this 4 band represents the significant figures. The third one represents the multiplier and the fourth one represents the tolerance. Moving on to fifth band, the third band of it represents the significant figure. Apart from this, the fourth band represents the multiplier and the fifth band represents the tolerance. When we move to the sixth band color coding, an additional sixth band is provided. This will measure the temperature coefficient. How will the resistance of the resistor vary with temperature? So the next question arises is, was it really that difficult to write the value of the resistor on itself? Why it is color coded? Can you guess? If you know, write your answers in the chat box. Well, the answer is very simple. Because we have to connect this resistor on a PCB or on a circuit board, and there is no top or bottom of this resistor. If the resistors are written the value on it, it will be quite difficult for us to connect it on the circuit board. Another common reason is that resistors are very small. So if we will write the value of the resistor, it will be very difficult to read. And also all these components, temperature coefficient, tolerance, etc. can't be written easily on it. So keeping in mind these factors, we do color coding of the resistors. Now we will talk about SMD resistors. You might have heard this name for the very first time, but don't worry, you will come across it regularly. What is these SMD resistors? They are fairly more smaller and accurate than the previous carbon resistors. They have silver conducting edges which make them more fast and more accurate than the previous carbon resistors. So how do we know the value of these SMD resistors? Here also, due to small size, it is very difficult to write its value. So we are going to learn two types of coding of this SMD resistors. They are E24 marked resistors and E96 marked resistor. What is an E24 marked resistors? Here you will see three numbers written on the resistor. The first two of which represent the significant digit and the third represents the multiplier. As you can see here, 20 is the significant figure and 5 is the multiplier. So the value of the resistance is 20 into 10 raised to power 5, which is 2 mega ohm. Talking about the E96 marked resistors, here there are two numbers followed by an alphabet. Both have different coding which you can search on the internet. For example, 01 represents 100 and C also represents 100. So we have 100 times of 100, which is 10 kilo ohm. So by now you have learned much about resistors. Before moving to the next section, let's try this question. This is a very fairly simple question. You might have tried this in your JE days. What is the color coding for a 5 kilo ohm resistor with a tolerance of 5%? Write your answers fast in the chat box. Try it out. Well, the answer is third, which is green, black, red, and gold. Why? Because 5 kilo ohm could be written as 50 into 10 raised to power 2. So 50 is 5 and 0. 5 represents green and 0 represents black. While 10 raised to power 2, in which 2 is the multiplier, so 2 represents red. And also the tolerance of gold is 5%. So we have the fourth color as gold. So next, move to the LED section. What are LEDs? You might have come across LEDs in your daily life very frequently. For example, the bulb which you have used in your home might be made of LED. So what is this? LED stands for light emitting diode. They basically converts electrical energy to light energy and they are made up of semiconductor materials. You can look for symbol of an LED here. So let's talk about polarity of LED. Before talking about polarity, let me ask you a very important question. Is polarity really important? What will happen if you connect the terminals of LED the other way around? Write your answers in the chat box. Try out. What will happen when you connect the LED other way around? It won't glow, right? Why? Because LED is basically a diode. And diode conducts current only in one particular direction. So if you connect the other way around, current will not flow and LED will not glow. Also, it is possible that LED might blow off. So if polarity is that important, we should keep in mind which terminal is positive and which is negative. So as you can see in this figure, one pin of LED is longer and the other one is shorter. So the longer pin is the positive terminal and the shorter one is the negative terminal. So here comes an important and interesting question. What if the terminals of an LED are cut down? Now how will you know which terminal is positive and which one is negative? Try out. Write your answers in the chat. Well, the answer is simple. When you see an LED, one side of LED is flat and the other one is rounded. The rounded side represents the positive terminal and the flat side represents the negative terminal. So keep in mind this. So I hand over to Chanchal for further presentation.
Hello guys. So we have seen the theoretical aspect. Now we are going to simulate some circuits on Tinkercad. So open the Tinkercad. The link will be in your chat box, or you can just type Tinkercad on Google. Just create an account, and by creating personal account and sign with Google, or you can use your IITG email. I already have an account, so I'll just sign in. Give me a minute. So once you have signed in, this is how Tinkercad looks like. So we are going to simulate circuits. So just go to the circuits section and create a new circuit. Okay. So I'll continue where Ayush left off. So we are talking about LEDs, right? So this is an LED. Just take it out. This is how an LED looks like in Tinkercad. So you can see it has a long terminal and a short terminal. So you can guess which one is positive and which one is negative. Obviously, the longer one is a positive terminal, which shows anode, and it is cathode. It's the negative terminal. So let's try to glow it up. So we need a power source. Search for some power source, battery. If I take this one, 1.5 volts, and if I want to glow it up, I have to connect it through wires, right? So for connecting wires, go to the positive terminal here and left click with your mouse. So you'll get a wire. You can extend it any way you want. If you want to bend it, just click once more with the left button of your mouse. And if you want to attach, whenever the red sign shows, connect it. Okay. And the negative one goes to the negative. Uh, I will start the simulation. So you can see it's glowing very dim. I stopped the simulation so you can see how it looks like when it's off. So it glows, but it's very dim. So I will connect some other battery with a larger voltage. I'll take the 9 volts one. The positive one goes to the positive. Let's check it out. What will happen if we connect it with opposite polarity? Okay, I've connected it with opposite polarity. So you can see it will not glow since it's reverse bias diode. Okay, so just connect it the right way. Now as you see, the LED burst out because 9 volts is very high power for this LED to sustain. So we have to consume power before the current goes through the LED. So tell me which component will we use? Okay, we'll use a resistor. Yeah. So I'm going to use a carbon resistor. You can see this is a carbon resistor. We can change its value by typing here. And as you can see, whenever I change the value, the color coding also changes. I'll go to the mega, then you can see its color changed from red to green. I'll keep it below. So just connect it in the series. Okay. Now you can see our circuit is complete again. I'll start it. Now you can see it's glowing fine. But this was a easy circuit, so we can make it like it open. But if there are complex circuits, so we have to use breadboards. So we have already learned about breadboard. Let's see how it looks like. This is a breadboard. In this breadboard, these all rails, horizontal rails, are shorted. It means they have the same voltage, the minus ones and the plus ones. They are just for reference. It's not a hard and fast rule that you have to connect the positive terminal of the battery to the plus one and minus negative terminal of the battery to the negative rail. It's not necessary. You can connect otherwise. And also you can, when you hover over them, you can see the shorted rails get highlighted by green tint. F, G, H, I, J are shorted and A, B, C, D are shorted. So you can connect something between F and E. So I'm going to make this circuit again in the breadboard. So for your reference, I'll connect the opposite way. I'm connecting the positive to the negative rail and negative to the positive rail. Okay. So I'll take my LED. Now I have to put the resistor. So can I put the resistor like here? Here, like this way. Tell me. Why? Why? I can't connect it, right? Because its both ends have the same voltage. So we have to rotate it, right? So for rotating, you have to use this button, or you can press R in your keyboard. So now it's horizontal. Or what you can do is place it like here. Place it here between the two rails, the gap between the two rails. Now we can complete our circuit. Uh, the wire goes here and this wire goes here. Okay, now you can see my circuit is complete. So I'll start the simulation and you can see it close well. Okay, you can also change the color of wires by clicking here if you want, so that it's not complex. But if you want your LED to glow on your own, like whenever I'm starting the simulation, it's glowing. But you want to glow it only when you press a button. So you can add a switch too. I'm adding a switch here and I'll take its input. It's a three-way switch. So the input goes to the middle terminal and the output I'm taking from the right one. Okay. So whenever the button is at left, it will not glow. But when the button is at right, it will start glowing. So this is the first basic circuit that you could make in your Tinkercad. I'll hand over to Hitesh for further explanation. And we'll have some more simulations in the later part, so stay tuned.
So, hello friends, myself Hitesh Kumar from Triple E department. So, before moving to our next component, remember that image we have seen in register part. Let's again have a look at it. 1 minute. Okay. So, I used told you about these registers. Uh, let's now come to know. Let's know another component of these PCB, this PCB. So there are some orange colored cylindrical components are there. What are these? If you know, write in the chat box. I can't show the chat box. 1 minute. Okay. So yes, these are capacitors. We all have studied capacitors in our 10+2 course that it is a two-terminal device that is used to store energy in the form of electric field. Here is the images of several capacitors that are used in the circuits, basic electronic circuits. Capacitor have a property that it allows to pass AC current and blocks the DC current. You can see that in this image. Capacitors are have different properties, so they are used in the different type of circuits like timing circuits, AC to DC conversion circuits, and some type of electronic filters. Uh, we all have studied about the capacitor, no, only about the capacitor in our 10+2. But here comes a new thing to us that there are two types of capacitor. Capacitors can be polar or non-polar. Hello. Sorry. It is not moving from. 1 minute sliding problem. So, what is happening? So capacitors can be polar or non-polar. For non-polar capacitors, we use symbol like this. And for polar capacitors, we use symbol like this. In the polar capacitor, there is a straight line in the symbol and a curved line in this. For the straight line represent the positive terminal of these polar capacitors, and curved line represents the negative terminal of it. Now, what happens if we connect wires of a polar capacitor in reverse order? That means negative terminal of capacitor to positive terminal of battery and positive terminal of capacitor. So yes, explosion. So I made that circuit I have tried to connect capacitor in that way. So it is lagging. Sure. Okay, so this is the circuit that I made. In this circuit, negative terminal of capacitor, positive terminal, positive terminal of capacitor to negative terminal of battery, in which series components are attached. Then when I simulate this, the capacitor is blast because there is an internal short circuit in the capacitor. Okay, so now let us know about some basic capacitors that are used in daily life circuits. So lagging हो रहा है यार. So there are two different circuits. In left side, that is a ceramic circuit in which ceramic is used as dielectric. Ceramic capacitors are non-polarized capacitors in nature and mostly produce capacitors in all type of capacitor. These are thermally stable capacitors. In right side, it is a electrolyte capacitor. Electrolyte capacitors are polar in nature, and these offers higher capacitance than than ceramic capacitors. By these points, you can get an idea where the ceramic capacitors are used and where the electrolyte capacitors are used. You can write their uses in chat box. I will give the answer after my part is complete. So as I say, this is a polar capacitor, and it may blast if we connect its terminal in reverse order. So it is necessary to have an idea which terminal is positive and which terminal is negative of this capacitor, because if otherwise it may blast or circuit may damage if we connect this into our circuit. So can you tell me which terminal is positive and which terminal is negative of this capacitor? Actually, there is no longer one or no shorter one, because of angle it is showing like this. So answer is something else. So I will give you answer that see this image. In this image of capacitor, you see here is a white band on it. This white band represents the negative terminal of capacitor. Okay, so this white band represents the negative terminal of capacitor, and other one is the positive terminal. But sometimes there is a black band instead of white band. In that case, black band represents the negative terminal. So we can find the terminals of these capacitors, polarity of these capacitors by the help of these white and black band. Now, come to the come to the next slide. Okay. So it is capacitance. Capacitance is very important for each capacitor because specific circuits need specific capacitances. For electrolyte capacitor, because you can see in this example, these are very big capacitor, bigger in size, so it easily can write capacitances and voltage ratings on itself. But for the ceramic capacitors, because these are very smaller in size, it is not able to write in itself. Ceramic capacitors in a 3-digit coded manner, in which first 2 digits represent the 2 significant digits and third digit represents the 10 base power. So as shown in the example. So I think it is sufficient for the capacitor. Now let's us move to our next component, that is inductor. Inductor is a passive device that is used to store energy, electrical energy in the form of magnetic field. As capacitor stores energy in the capacitor stores energy in the electric field, and inductor stores energy in the form of magnetic field. Capacitor blocks the AC, sorry, blocks the DC and allows to pass AC. And opposite of capacitor, inductor blocks AC and passes the DC current. Okay, so inductors are used in the different type of the circuits like radio circuits, relays. You can many of you might have seen this blue color component in basic home basic home and basic home devices. This is nothing but a relay. Relay is used to control the inputs of our basic home devices. It is to making a relay, we use inductor in it. Now look at this picture. What these are? Are these resistors? Hello. Anyone? Are these resistors? So these are okay. So by seeing this picture, it comes to your mind that these are resistors because pictures similar to this we have seen in resistor section, but these are not resistors. These are inductors. That looks like that looks similar to the resistors. These are inductors that looks similar to the resistors. Inductance of these inductors we can calculate by color coding printed out on them. The color coding of the inductors are similar to the color coding of the resistors. So now I have a question for you that you have seen several images of inductors in which like this, in which in which a copper wire is wind. Sorry. In these type of inductors, there is a copper wire wind on an insulator cord. So can we make a inductor at home by winding a copper wire? So can we make an inductor at home by winding a copper wire? Yes, we can. The answer is yes. We can make an inductor at home by winding a copper wire. So now it is our inductor part is here. Our inductor part is over. Now come to our next component, that is diode. We all have studied about diode in our 10 plus 2. Diode is a two-terminal device that allows the current to flow in one direction only. Diodes are made of semiconductor materials like silicon, germanium, etc. You can see in this picture, if diodes are connected in the forward bias, it allows to flow the current. But if it is connected in reverse bias, it not allows to fast flow the current. You all have studied about the diodes in your 10 plus 2, but I think you might not have seen how diodes looks like in real life. So for that we have a picture in which several diodes are presented. Uh, in this picture, you can see several different diodes that are used in the real life circuits. In the right side of this picture, you can see there is a simple diode and with its symbolic representation. The arrow sign in the symbolic representation of diode represents the anode terminal, and the line part denotes the cathode terminal. If current is come from the anode to cathode, diode allows to flow it because it is in the forward bias. And if current comes from cathode to anode, it is block the current because it is in reverse bias. Now you can see you can see the importance of diode by this circuit. It is a non-general clipper circuit clipper circuit. Clipper circuits are used to remove the some parts, some specific bands, voltage bands from the input signal. In this circuit, you can see that AC sine wave is given as input to this circuit, and the output in output diode removes the negative part of the AC sign voltage current or AC sign current. So it is a very important use of diode. We can now use the equipments that are not able to capable to run on the negative current. So now we can run them. I think it is sufficient for the diode. Now move to our next part, that is transistors. Transistors for the electronics domain, because mainly most of the most of the equipments that we are using in at home, like our televisions, mobile phones, laptops, are based on the transistors. uh, Transistor, there are so many type of the transistors, but BJTs and MOSFETs are commonly used transistors. MOSFETs are the basic building blocks of the modern computers uh, because processors and memories of modern computers are made based on the transistor only. Because transistor is a very big part, we cannot cover it completely into this workshop. So left it here and come to our next component, that is IC. You can see these black components with so many pins is IC. IC referred for the integrated circuit. Integrated circuit is a set of electronic circuit on one set of electronic circuits on one small flat piece. Flat piece is called chip. In a small level of integration, there can up to 10 circuits can be implemented into the a single piece or chip. In ultra large scale integration, there can be 10 billion plus. Uh, uh, in ultra large scale integration, there can be 10 billion plus circuit can be implemented on the single piece of chip. So you can see how why these components are important. Why these ICs are important? Because every component that we have encountered with like gates, multiplexers, demultiplexers, flip-flops are packed into the ICs. Now you can see in this image there are a notch present on this IC, in this IC, and is also so why, and I think there is a dot also present on that, but this picture, because of picture, we cannot see that dot. So why these notch and dot are present on these ICs? Because there are very large number of circuits implemented on the single piece of chip. Single piece of chip. There is a large number of pins in to control the inputs and outputs of IC. So 1 minute, फिर lag हो गया ये. Okay. So by the help of these notch and pins, we can identify the numbering of the pins. We can identify the help of these notch and dot the pin number 1, and then according to pin number 1 we can got the all remaining pins like as they go in sequence. You can so that in this example. See that in this example, they go 1 to 7 in the sequence, then 8 to 10, 8 to 14 in other way. So these notch and dots help us to identify the pin numbers. Now next. So shit. So this is an basic IC that is used in the our circuits. So you can find out the number of IC printed on this. There is written NE556N. So this is an 556 timer, dual timer 556 IC. There are so many ICs present in electronics domain. So to identify the task of each ICs and differentiate them from other ICs, there are given numbers to each IC. We can identify the each task of each IC with this number. This IC number is 556. So this is a dual timer IC that is used in some basic circuits. So we more know about timer ICs in our subsequent workshop. Please watch them also. So do you want to know how it looks like from inside? How an IC looks from inside? Do you want to know how it looks like from inside? So here is a picture for you. I have a picture for you. So by this, 1 minute, so this is an internal circuit of an 556 timer IC. You can see how complicated circuits are made into a simple single piece of chip. So I want to give you an idea about.
Have you ever heard of a guy named Peacemaker?
I want to give you an idea about the size of. Actually, this is called a chip die. This internal circuit is called a chip die. I want to give some idea about the size of chip die to you guys. So you can see these ICs. In these ICs, there is a small hole in between these ICs. The wall circuit can be the wall circuit or chip die only implemented in these small pieces. So you can get some idea that the original circuit size is very less than as compared to the size of a chip. So now my part is over, and now I hand over my control to Tarannum. So Tarannum.
Hello everyone, I am Tarannum and let's explore more about the general terms. So first, function generator. Do you know what is a function generator already? Function generator is used for setting frequency to generate different waveform. Various waveform we can set in the function generator are the sine wave, square wave, triangular wave, and sawtooth shapes. Here we set the frequency we want using buttons shown and also set what type of waveform we want according to the experiment. These knobs here are to connect it to circuits and buttons to set the digits of the frequency. There are various parts you can see here which you will learn once you explore it your own. This is the display where we can see what is the frequency set. Then comes power supply. Power supply is an electrical device that supplies electrical power to an electrical load. Don't confuse it to power source like batteries and cells, as power supply convert electric current from a source to the correct voltage, current and frequency to power the load. That is why sometimes it is also called as electrical power converters. All power supplies have two power connections. One is power input connection, which receives energy in form of electrical current from a source, and one is for power output rail connections that deliver current to the load. As you can see here, this gives the voltage reading here, and this gives the current reading here. And of course, this is the on and off switch. Then let's go to the multimeter. Multimeter is a measuring instrument. We can measure voltage, current, and resistance by this. Some of them even can measure the temperature. Here you see is shown for the current measurement, and this knob is for setting the DC and AC voltages. And you can set the various things here too. Then let's go to the next, which is oscilloscope, which is a very popular term in electronics, and even not even in the engineering, it is also used in research and medical fields too. Now let's learn about oscilloscope, which is also informally known as a scope, O-scope, or a CRO and DSO. As you know, it's difficult to measure one-to-one reading in the experiment, so we need graphical measurement, right? Oscilloscope graphically displays varying signals, voltages, usually as a calibrated two-dimensional plot of one or more signals as a function of time. An analog oscilloscope is typically divided into four sections. One, the display. Second, the vertical controls. Third, the horizontal controls. And last, the trigger controls. As you can see, there are various knobs to connect it into our circuit. This list is never ending, but we cover the most important ones. So let's move forward and listen from Gayatri.
Hey guys, this is Gayatri. Uh, we have all come across the word microprocessor quite a lot of times and could have wondered what all that hustling around it was about. But we can't just go straight at it without knowing the basic of what it's about, right? And that's where we come face to face with logic gates. These are the most fundamental part of digital electronics. Logic gates can get from 1 to n number of inputs, but irrespective of the number of input we give a logic gate, it can produce only one output. And yes, it is on and only. And these are what makes up all the complex and application specific circuits like flip-flops, latches, etc. Some of which you'll also see in the later sections of this workshop. But before we move on to learn about the different types of gate and what each type does, we'll need to know about something called the logic level. Two logic levels which we come across in digital are 0, which represents lower false, and 1, which represents higher true. All logic gates comprises of millions and thousands of digital systems comprise of millions and thousands of logic gates. So all these systems can be constructed only using 3 basic gates, and these are the AND, OR, and the NOT gate. We'll see about few other logic gates also in this section, but in the end, all those are also combinations of these 3 basic gates. AND gate. The first gate we are looking at is the AND gate. It gives a high output only when both its first and second input is high. This applies to the n input AND gates also, which means that all the inputs need to be high for this gate to give us a high output. Even if one of the input is not high or low, we get the output as low. OR gate. For this to give us a high output, the first input or the second input or both the inputs should be high. A false output is produced only when all the inputs are false. The next gate we are going to look at is the third basic gate, which is the NOT gate. This produces the negation of its input as the output. There are no n input NOT gates. A NOT gate can only get one input. And since the output we get from this gate is the inversion of the input, we also call this as the inverter. NAND gate. NAND stands for not AND, and from its name we can understand that it is a combination of the AND gate and the NOT gate. And also from this representation we can see that it's the negation of the AND gate. The next gate we are going to look at is the NOR gate. From all this info you have learned till now, can you guess what basic gate it might comprise of? Answer in the chat box. I'll give you a few seconds. You're right if you guessed it to be the NOT and the OR gate. From this representation, we can also see that it is similar to the NAND gate, and it is comprised of 2 of the basic gate, which is the NOT and the OR, and it is the negation of the OR gate. XOR. This stands for exclusive OR. In case of 2 inputs, this would give us a 1 when the inputs are different and give us a 0 if the inputs are of the same logic level. So there is a general thumb rule to easily remember for which input we get a high output in XOR gate in case of more than 2 inputs. So here you have a representation of a 3 input XOR gate using 2 XORs. Can you find the pattern in the input combinations? Visualize sending in different input combination to figure what is the similarity between all those combinations which give us a high output. I'll give you few seconds to answer that. Yeah, it's right. If you have found the pattern, you would also have figured it out that all the input combinations which give us a high output have odd number of 1 bits or high inputs in them. Moving on to the next gate, which is the last gate we are going to look at. This is the XNOR gate. from the gate representation, we can see that it is the negation of the XOR gate. So here's a simple question. We know that the XOR gate gives us high input in case of odd number of 1 bits present in the input combination. So if it is the negation of that, what is the pattern the input combinations follow here? You're right if you guessed it to be the having even number of 1 bits in them. And we have come to the end of this section, and we are well aware that practicing and testing on what you have learned is as important as learning something new itself. So before we jump into the next session, we'll do a small exercise. This is a simple question if you clearly did understand what each of the gate does. Looking at the question now, we have a truth table here, and in this blue block, you have to put in a 3-input logic gate so that these inputs ABC gives us the output Y according to this truth table given. I'll give you a few seconds to go through the truth table. So now looking at this truth table, we see that wherever Y is high, yeah, that's right, XNOR gate, yeah. So wherever Y gives us a high output, we see that the input combination have even number of 1 bits in them. So the answer for this question is a 3-input XNOR gate. I'll pass it on to Chanchal for a small simulation using logic gates. Thank you.
So you have seen about logic gates. So in the circuit board, we cannot connect logic gates directly. So they are present in ICs, in the form of ICs. You can see I have listed some ICs like 7408 IC is AND gate, and 7400 IC is NAND gate, and 7404 IC is hex or inverter, hex inverter, that is a NOT gate. So we'll just add hex inverter in our previous circuit. Okay, open Tinkercad and just put it in series. So I'll search for hex inverter. So tell me, can I place it here? Hello? Anyone? Okay. Yeah, we can't place it here because most of its terminals will get shorted. So we have to place it in the between 2 rails. Okay. So we see it's this terminal shows power. So we have to connect it to the positive rail. This one shows ground connected to the negative rail, and we'll take input from the switch. It shows input 1, and the output 1 will go to the LED. Okay. Now we can see our circuit is complete, and I'll start the simulation. So now you can see most of my components are burst out because the LED, the voltage of battery is very high. So instead of this, instead of changing many battery components, I'll just add power supply. You have already learned about power supply. I'll add this one so that I can change the applied power whenever I want according to our needs. This one here, and this goes here. So I'll start the simulation. Still 5 volts is high for this circuit. As you can see, our hex inverter is burst out. So I'll reduce it to 2.7. Okay, now it works fine. So previously, when the switch was on left, the LED was not glowing, and when the switch was on right, the LED was glowing. So now you can see it's just reversed. So a NOT gate is working perfectly fine. Okay, this is it for now. I'll hand it over to Teja.
So, hey guys, I'm Teja, and today I'll be covering a flip-flops part. So, many of you must be new to the flip-flops, and the first thing will pop to your mind is bathroom ka chappal. But no, as you can see here on the bottom, this is a basic flip-flop circuit. So, let's learn about flip-flops. Ever wondered how computers store data? I'll wait for 15 seconds. If you know the answer, type in the chat box. So, data is stored by the help of flip-flops. In digital electronics, data is stored in binary form, right? Ones and zeros. So, a flip-flop can store one bit of data, 0 or 1. It can switch between the states 0 and 1. As the legend says, flip to one state and flop back to another state. That's how the name flip-flops originated. So, do you know what commands is shown in binary state? And again, I'll wait for 15 seconds. If you know the answer, type in the chat box. So, if you guys have guessed it right, we use a clock. For those of you who don't know a clock, I'll explain it. So, a clock is a signal that oscillates between high and low voltages. That is digitally 1 and 0. So, as you can see here, the clock goes from 0 to 1, oscillates between 0 to 1, and is a periodic. So, flip-flops are sensitive. Now, some of you guys are like, I have no idea what that means. So, don't worry, let me explain it. It means that flip-flops change state 0 and 1 under the influence of clock's positive edge or negative edge. So, what are these positive and negative edges of clock? So, in electronics, a signal is defined as the transition from a high to low or from low to high. So, in summary, a positive edge is transition from low to high, and a negative edge is a transition from a high to low. So, types of flip-flops. There are basically three types of flip-flops: D, JK, and T. So, D flip-flop is the most widely used flip-flop. In the bottom left corner, if you can see, there's the diagram of a D flip-flop. As you can see on the left side, this is the D input and this is the clock input. And here's the Q output signal and Q bar signal. Now, if you see the truth table here, as you can see, if you give the D input 0 and the Q output also changes to 0, provided the clock has a positive edge. This is the most important part here, guys. Remember it. This upward arrow represents a positive edge. So if you change the D input to 1, the Q output changes to 1, provided the clock has a positive edge. Let's see how Q changes with clock. And you might want to listen to this. So, as you can see here, we have three signals: one clock, one D input, and one Q output. So let's see. Let's look at the D input signal. At the first time when D input signal changes from low to high, the Q signal still remains low because there was no edge in the clock when D input changed. But eventually, after the nearest clock edge occurs, the output changes to high. This is what we call its sensitivity of flip-flop. So again, if you see here, when D changes from high to low, the output still remains high because there was no edge in the clock. And after the edge occurs, again it will change to low. So in summary, flip-flop's value changes only when edge in the clock occurs. If you understood what I have said before, you must understand this. Use of flip-flops. Flip-flops are generally used for in registers, counters, and buffers. Registers are generally storage elements, and buffers are extensions of registers. Counters are devices that generally count. So a counter in a layman's term is a device that counts. Simple enough, right? So a counter increases or decreases the count when the clock edge occurs. A common example for a counter is a stopwatch. As you can know, stopwatch just counts time, right? So counters are used there. Let's talk about 4-bit counter. What does it do? It just simply counts from decimal 0 to 15. If you convert decimal 0 in 4-bit binary, simply 0000 and 15 1111. And that's pretty much it. Simple enough, right? So this is the circuit of a 4-bit counter. Let's have a look at it. As you can see, 4D flip-flops are used for this counter, and a clock is given on the left side. And the output is Q3, Q2, Q1, Q0, Q3 being the most significant bit and Q0 being the least significant bit. Now, for those of you who didn't understand this properly, don't worry. We'll have a live simulation and everything will be clear for you. As you can see here, I have a 4-bit counter ready with me. So let's start the simulation. Okay, first, I have a question for you guys. As you can see, I started the simulation here, but the counter didn't start counting. Can any of you tell me a reason why? If you know the answer, type in the chat box. So if I guessed it right, I didn't start the clock simulation. As I've told earlier, flip-flops are extensive, so they change the output only when the edge of the clock occurs. So let's start the clock animation. Now, as you can see, the counter starts counting. So counter adds 1 bit for every previous number. And as soon as the counter reaches 1111, it again resets to 0. So this is basically a counter. And you can create 2-bit counter, 3-bit counters, and even if you want, you can custom media counters. Like this counter is counting from 0 to 15, but if you want, you can make it count from 0 to 10. We just have to set 10 as the reset value. So let's conclude the counter part, guys. Now I hand over to Chenju.
So guys, you have already seen the basic simulation of a 4-bit counter on Deeds. So first, I'll tell you something about dual D flip-flops, and then we'll have another simulation. Okay. So what is a dual D flip-flop? You can guess it by its name only. It contains two D flip-flops. Okay. So here are some questions. Can we use dual D flip-flop as a single D flip-flop? Type in the chat box. Yes or no? Okay, leave it. Yes, we can use dual D flip-flop as a single D flip-flop, as we can use single side of this IC. And what is this PR and CLR in the picture? These are not of any use to us right now, so we are not going into deep. So just leave it them for future. Can we use only D flip-flop for making a counter? So no, we can use any other flip-flops like JK flip-flops and all, but we are using dual D flip-flop because it's only flip-flop that is available in the Tinkercad. Okay, that was the answer to the second question also. So now we are going to make a 2-bit counter on Tinkercad. So open your Tinkercad. This is the circuit available. Let's make it together. Okay. I'll just split my screen so that we can use both of them. Now you can see. So let's take a breadboard first. I'll take a larger one. And we'll need a 74HC. It's a dual D flip-flop, okay. So you can see the 1, 4, 14, 13, and 10 are connected to voltage. So first we'll add a battery. Okay. So instead of battery, I'll add a power supply so that we can alter power supply. You guys can try to make it on your own. I'll do one thing. I'll also connect these two so that I can use both of the rails. Okay. And you can see the 7th one is connected to ground. So ground would be our negative terminal. The pin number 2 and pin number 6 are connected. So this is the pin number 2 and this is 6. I've connected them. The third one will go to the function generator. So I'll import a function generator. It goes to the third pin. And this one goes to the ground. What else is there? 12 and 8 are connected. Yeah. If you have any doubts, you can type in the chat box. What else we need to connect? Now I think our circuit is almost complete. Now we just have to connect the LEDs for outputs. Okay. So I'll need two LEDs for 2-bit counter. I'll place one of them here and another one here. The 5th wire goes to the LED negative terminal, and it will have a resistor in series. Okay. Also has a resistor in series, and ninth one. Okay. The 5th and 9th are also connected. Now 5th and 11th. And this goes to the higher voltage. This one also goes to the high voltage. Now you can see our circuit is complete for a 2-bit counter. 2-bit counter counts from 0 to 3, that is 0, 0, 0, 1, 1, 0, and 1, 1. So I'll start the simulation. I'll reduce the frequency so that it changes in 1 second. Now we can see the bits. It's 0, 0, 0, 1, 1, 0, and 1, 1. It's the simulation of a 2-bit counter on Tinkercad. I'll maximize it. Were you able to make it on your own? Anyone? No one? It's okay. So now it's complete from my side. So now you have a task to do. You have to create a simulation of a 4-bit counter on Tinkercad and submit your response in this form given. There's a hint. You can use two 7474 ICs, and to submit your response, I'll tell you how to get your Tinkercad link. So this is my form. First open Tinkercad, go to send to, and invite people. On invite people, you can copy your link for your project and submit it here. I'll fill it up. And paste it. You can also get a receipt of your responses and just press the submit. We'll be checking all your responses and tell you if there's any discrepancy. So please submit.
So yes,
whenever you are completed.
Chanchal.
Thank you.
Guys, our workshop is over now. So just before ending the workshop, I'll show you something Did you guys see this thing? This is our breadboard. Okay, and this little thing is IC over here. Okay, so the thing which you are doing in this Tinkercad, we can do this in the real part. Obviously, Tinkercad is just a substitution. So just give me a guess, like what is this? Okay, anyone? Okay, fine. This is capacitor. Okay, so this is our battery, and just give me a guess. What is this? This thing. What do you think this is? Is it a resistor or inductor? Okay, yes, this is inductor. Many of the guys are confused between inductor and resistor because both of look the same, and we have many things over here. So those who are in the campus there, they can come to the club, and those who are not there in the campus, just wait for some time. You guys will be invited to the campus sometime, and we all will be present over here in the club, and then it would be a great fun. Okay, so guys, we will end it here, and just in the chat section, don't forget to subscribe our social handles. Just go there and check out all our events over there. Okay, so okay, so and also please fill the feedback form too. Thank you guys for joining us. Okay. And we will be contacting you personally after your submission that it is correct or not. It's a very little assignment. You can do it in 1 day. There is no deadline for the assignment because it is just for the knowledge purpose. We will let you know if it is correct or not. So officially the workshop is ended. Thank you for guys being joined with us. Okay, yes. Next workshop would be on the very next weekend, maybe the next Sunday. Yes, you can use the YouTube. That means you can see our videos on the YouTube. Okay, thank you guys.